We have next example. Before you are going to do this problem, just please keep in mind that you have to first look at these variables. In this case, D represents the most significant bit. That's why you have to write D on the left side of the K-map. Simply D, C, B, A. This is the proper setting for this Karnaugh map. We're going to have ones in following cells: 5, 6, 8, 9, 10, 11, 12, and 14. Let's check how many groups we can create. Remember, we'll try always create the biggest group as possible. So I have 4 ones in this row. So this is going to be my one group. And my other group is going to be this one. I'm going to have another 4 ones, and this one is going to be by itself, and this one I'm going to join with this one. So I have 4 groups. 1, 2, 3, 4. I'm going to start from the biggest ones. I have this group. This group is placed in 4 columns and 1 row. We always copy down everything, whatever is at the side of the single row, because when we have this group placed in 1 row, we simply copy down everything, whatever is at the side. So I have D, C naught. Keep in mind that anytime we have group in 4 columns, we simply ignore everything whatever is at the top, because we do not have common variable for these 4 columns. Another group, this one, is placed in 2 rows and 2 columns. The common variable for these 2 rows is D. The common variable for these 2 columns is A naught. So I'm finished with these two groups. Now let's talk about this one. This one is placed in 2 rows, and the common variable for these 2 rows is C. And at the top I have B A naught. Okay, I'm finished with this one. And this one is D naught C, because this one is placed just in 1 cell. So at the side of this cell I have D naught C, and at the top I have B naught A. Let's check if we can factorize something over here. As you can see, we cannot simplify very much this expression. Maybe some simplification is going to come out with the implementation. So we have AND gate with 2 inputs. I have input D, and I have input C naught, and I have input D, and I have input A naught. I have input C, B, C, B, and I have A naught. So instead of using 2 inverters, you can use 1 inverter. You can make connection to this one and simply connect to this gate. Please notice that this is connection. Anytime you see node, means this wire is connected to this terminal. These terminals are not connected to this wire, okay? So we have 3 inputs, C, B, A naught. Next we have 4 input AND gate with inputs D naught, input C, input B naught, and I have input A. Please keep in mind that if you are going to look at the circuit, physical circuit, you are going to see that all these are connected together, all C's are connected together, all B's are connected together. I didn't connect them because I don't want to mess up the picture, but in real life, all these points are connected together. I mean B's, C's, A's, and D's. Now, all these AND gates are ORed together. These are the solutions to my problem.